Hi, I'm Richard McKenzie, co-author of Microeconomics for MBAs. This video module is going to be about indifference curves, how they are constructed and how they can be used to derive the law of demand and how they can be used to address policy issues. In order to give concreteness to the notion of human preferences, economists have devised the concept of indifference curves. An indifference curve is a set of points on a graph that represents the same total value to the consumers. Consider this graph in which we have drawn standard indifference curves. That is, we have indifference curve I1, in which we have various points or combinations of good A and good B. You have at combination A this combination of A and B, A1 and B1. At combination little b, we have A2 of good A and B2 of a good B. By putting them on the same indifference curves, we say that the consumer is indifferent between combination A and combination B. This implies that the value of combination A is exactly equal to the combination B, and for that matter is equal to combination C and combination D. Now, we know that there are higher indifference curves because you can take a combination like E. At E, there is more of both goods. As a result, E has got to be of greater value than B. Now here we have simply drawn in the indifference curves, and we assume that in drawing these curves there is a diminishing rate of marginal substitution. That is, in order to move from B to B3, the consumer must be willing to give up A2 to A3. To move from combination B4, the consumer is willing to give up even less of A, that is A3 to A4, and as we go on down here, the amount that we are willing to give up of A for an additional unit of B begins to diminish. Now, again, the curves are drawn by assumption of diminishing marginal rate of substitution. I prefer to derive the indifference curves from the assumption that more is preferred to less. Consider this empty graph. This graph is everywhere dense with combinations of A and B. We can pick out a point like little a. And we can ask ourselves, where is the indifference curve along that point? Well, if we start with the presumption that more is preferred to less, then we know that the individual cannot be indifferent between point A and point B. Why? Because there's more at B than at A. And the individual cannot be indifferent between C and A because there's more at combination A than at C of both goods. So we know that indifference curves cannot run up and to the right. We know that they must somehow come down and to the right. We know that combination C is preferred to A because there's more of B at C than is at A. Same quantity of A. There's going to be A1 of A. However, we also know that combination D is also less preferred to combination A. So D is less preferred than A. C is more preferred. Now, if we're at D and we're less preferred and we move in this direction towards C, we go from a point of less preferred to more preferred. There's got to be a point like E that is equally preferred to A. we could go the same way from this point to this point, and there's going to be some other combination like F that will be of equal value to E, which will be of equal value to A. If we go from point G, which is less preferred to A because there's less of B at G than at A, to a point like H, which is more preferred to A because there's more of A at H than at A. Then if we go in this direction, we go from a position of less preferred to more preferred, and as a consequence, there's got to be a point like I that is of equal value to A. We could do this for other points on the graph and come out with other combinations that are of equal value. Moral of the story is that the indifference curve has got to look something like this. We could start off at another point, call it X. We could make the same kind of analysis, and we could conclude that there is another indifference curve that looks like that. Now, we know that this graph is everywhere dense with indifference curves. We know also that I1 is a set of points that is less preferred to all points on I2. Why? Because X has more of both A and B than does little a. So if X is preferred to A, then a point like Y has got to be preferred to A. Now the question is how are these indifference curves downward sloping? Do they look like wiggly lines like I have here? Do they look kind of bowed in toward the origin, bowed out from the origin, or what do they look like? Well, first off, in terms of this graph, we can pretty much rule out an indifference curve looking like this. And the reason is that there's a basic proposition in economics that more is preferred to less. So if you have a combination like A prime and a combination like B prime, we know that those two combinations can't be on the same indifference curve. Why? Because there's more at both good at B prime than at A prime. So the indifference curves can't buckle back.